Unit 4B, Lesson 4, Create Equations that Describe Relationships. In this lesson, we're going to continue to look at the quadratic equation, but now we've looked at it in many different forms. We've had our standard form, y equals ax squared plus bx plus c. We've gotten it down into factored form, written as two linear binomials multiplied by each other. And now we've also talked about vertex form. So what is each of these different types of equations? Why is that beneficial? What does it allow us to determine about the function or the graph of the function? That's what we're going to look at in this lesson. In the first example, we're told that all of the equations below are equivalent. Determine what each of the different forms allows you to determine about the function. So in the first one, we have standard form, and then we have factored form, and then we have vertex form. So first, talking about standard form. What does this allow us to quickly determine about the function, about the graph? Well, if we're in standard form, we can quickly identify the y-intercept of the graph, where we cross the y-axis, because if we plug 0 in for x, which by definition is where the y-intercept occurs, these first two terms are going to be gone, and we're just going to be left with 24. So in the first function in standard form, we can quickly identify the y-intercept, and that's going to occur at the ordered pair 0, 24. Now moving on to the second form, which is factored form. This we should kind of recognize what this allows us to determine. When we were in factored form, the next step we took was set this equal to 0, use the zero product property, find those x values. In this case, those two x values would be -6 and -4 if we solved for them. And we said those solutions, those x values, are the same as the x-intercepts on the graph. So when we're in factored form, we can quickly identify the x-intercepts. In this case, the ordered pairs would be -6, 0 and -4, 0, because when we have an x-intercept, the y value is going to be 0. Now to the third form, and this should be really easy because this is what we just talked about. If we are in vertex form, that allows us to quickly identify the vertex of the graph. And then not only can we quickly identify the vertex of the graph, we can determine whether that is the maximum or the minimum value by looking at our a value. In this case, our a value is positive. We know the graph is going to open up. It'd be a U shape, so the vertex is going to be a minimum value. So we can quickly identify the vertex, which is going to occur at the ordered pair -5, -1. So in standard form, we can quickly identify the y-intercept. In factored form, we can quickly identify the x-intercepts. And then in vertex form, we can quickly identify the vertex. One thing you should notice about the x-coordinate of our vertex, that is always going to be in the middle of the two x-intercepts. So we saw our two x-intercepts were -6 and -4. The middle of that, -5. Now to the second example, which is going to essentially be the same idea, except we're given the standard form of the equation. We have to find the factored form and the vertex form. Once we have the other forms, then we can identify the key features like we just did in the previous example. So first, looking at the standard form, y equals x squared minus 3x minus 28, we can identify the y-intercept of the graph. Because we plug in 0 for x, these first two terms eliminate, so our y-intercept would occur at the ordered pair 0, -28. Next, we can quickly identify the x-intercepts of the graph by getting it into factored form. Factors of -28 that have a sum of -3, -7, and +4. So we factor this into x minus 7 times x plus 4. Then we use the zero product property to find these two x values. This x value would become 7. This x value would be -4. So the two x-intercepts of the graph occur at 7, 0 and -4, 0. Then the last one is identifying the vertex. So we use completing the square to get it into vertex form. The value we have to add is 3/2 squared, which means we have to subtract that later on. This factors into x minus 3/2 quantity squared. I know 3/2 squared is going to become 9/4, so I have to get a common denominator, multiply this by 4/4. So I have -112/4 minus 9/4, which becomes -121/4. Now I have it in vertex form. I can quickly identify the vertex of the graph that occurs at 3/2, negative 121 over 4. And that is going to be a minimum value again because our a value out in front is positive. So in standard form, identify the y-intercept, factored form, identify the x-intercepts, and vertex form, identify the vertex.